Hello and welcome. Next up, we got Olivier Gaudin. He's the CEO and founder of Sonar, and he's going to talk about clean code. His explanation is that code should be secure, robust, reliable, easy to maintain, and durable. Much like food should be healthy, cheap, easy to prepare, and you know the problem that we have. We build on top of thousands of NPM packages. We build on third-party code. We randomly copy it from Stack Overflow. And how do you know that the code that you write or the code that you got from ChatGPT actually is good and clean? And that's where Sonar and other products come out. We just had a good chat about it because I worked on WebHint when I was in Microsoft and seems to be doing similar things. So if you want your code to be cleaner, now you're going to learn about it. He's got lots of information to give you. Again, if you have questions, ask them in the app. If we don't have time for Q&A, he will answer them later on as well. So without further ado, Olivier Gaudin, please.
Thank you very much, Chris. Hi, everyone. So today I'm going to talk about clean code. And first, before I do this, I just would like to introduce Sonar. So been doing this for 15 years. Sonar is a set of products which do a solution. Probably know Sonar Cube, Sonar Lint, Sonar Cloud. And what we do is really try to solve this, what we call clean code problem. And this is what I'm going to talk about today. So first off, when we think about software, I think sometimes we forget that software is made of code, and actually code is the main asset for software. If you think about pretty much anything else in a software, everything else is either disposable or sometimes it's, I would say, useless, but it can certainly be replaced. If you think about code, you cannot replace code. Code is going to basically dictate what your software is going to do, how it behaves, and how your software is going to perform. And very often, we tend to focus a lot on what we call building the right software, which is, hey, is my code doing what it is supposed to do, which is, does it do the functionality, does it answer the business need? And we tend to forget about the technical part of the code, which is, am I building the software right? Am I writing the right code? And this is super important. This is what we do. We help organizations to build better code. So basically, if you recognize this, this is actually a tree, which is on this slide. It's a modern tree. Code is like a tree. You have the emerge part of the tree, which is you want your tree to be beautiful, leaves, trunk, branches. You want your software to do what it is supposed to do. But in order to achieve this, you need to make sure that your tree is going to have very, very strong roots. And we think this is one of the most important in software. So clean code. Let me talk a little bit about clean code. What is clean code? Clean code is what is going to enable these roots to be strong. And we believe that there are really 4 things you should take care of. One is you want your code to be consistent. What do we mean by consistent? It should have pretty much a single style. It should have consistent constructions, which is if you are going to solve a problem in your application, you should actually succeed to do it always the same way. Why is it so important? Because applications are not written by a single developer. They are written by a team. And if you want the team to be able to actually collaborate to build the software, you need to make sure everybody is doing that the same way so that when you read code, when you change code, you don't spend too much time or you don't go into surprises. So consistency is the first pillar of clean code. The second thing is the code has to be intentional, which is, I'm sure you have seen this, you write a piece of code, 6 months later you open the file, and you start to wonder who the hell wrote this, and then you realize this was you, and you really felt smart when you wrote it, and suddenly you felt it was not so smart, and you simplify it, you make it more intentional, and you basically change it. If you have like contradicting statements in the same method, which one is going to win at the end? You don't really know. That's one part, but the second part is also, sometimes you don't need to not be intentional, but you are actually unintentionally misleading people. Think about forgetting to close resources. If you don't sanitize some input from users, you don't do that on purpose, but this is going to lead to your software not behaving the way you want. It might be your database is crashing. It might be that it is actually possible to do things you were not expecting people to be doing with your software. So basically, your code is not intentional. The third part is about adaptability, which is, by definition, and I'm sure you would agree with this, software is going to change. It doesn't matter what software you're writing, it is going to change. Whether it's because it's not doing exactly what it was supposed to do, whether business is changing, requirements are changing, the law is changing, your software is going to change, and you need to be able to change it. And when I say you, I mean the team needs to be able to change it, so it's not a single person here. So you need to build it in a way where you know you will be able to change it without spending too much time and maybe doing too much effort. And finally, the code should be responsible. So what do I mean by responsible? I mean, of course, you cannot store code. You cannot just take code somewhere and have it in your software. You need to make sure you follow licenses. You shouldn't make comments about your colleagues in your code, like you should solve problems outside of the code. You shouldn't do things like storing secrets, passwords, etc. These are really bad practices that can lead to problems in your organization. So you also want your code to be what we call responsible. And this is what we mean by clean code. Now, do you need your code to be perfectly clean? No, you do not. It's totally okay that some of the code is more or less good, a bit chunky. That's fine. The problem is that if this is too bad, then you're going to spend your life fixing it. And when I'm saying fixing it, it's going to take you a while to read it, to understand it every time you make changes. It's going to take more time. Everybody is going to be wishing that nothing bad happened when you push code into production, and then you have other teams like operations, infrastructure, security, which are going to keep coming back to you to fix problems. Like, we have a security vulnerability here. We have this memory leak there. So you are going to have to spend your time to basically do some rework, which is not really interesting, not really valuable. So basically, if your code is clean, if the code that you produce is clean, you actually, first off, you do a good job, which is you do a better job, at least. Second is, if your code is not clean, it's likely that every time you need to change it, you are going to have to write it. So basically, it becomes disposable code. If your code is clean, you are not going to waste precious time to read, understand the subtlety, pray when you are making changes that it doesn't break anything. And all in all, you are going to have a higher velocity, a higher throughput, and the whole team is going to have this. So that you can spend your time in things that are more valuable for the organization, more valuable for you. You can do more innovation, and you can learn more things. I also think it enables that you really own your code, because when people are coming back to you to change your code because it's not secure, it's not stable, not robust, actually, you don't really fully own your code. You don't fully do your entire job. Some other people have to tell you what to do. And I want to highlight something here, which is, I think the more we go, especially with things like generative AI, the more code we are going to write. So this is going to become even a bigger problem, which is all this code that is generated is going to be generated by tools who sometimes will make it clean, sometimes not. But for sure, even if it's clean locally, even if it looks good, it might have some impact elsewhere. So we need to really be careful with this. It really doesn't work anymore. Right. So how can you know whether your code is good or not so good? I would say if you don't know, it's probably that it's not so good. So for a long time, the best approach to know was to actually look at what happened when developer reads the code, what are their reaction, and you could deduct whether it's good code or bad code. We can do much better nowadays. There are plenty of tools out there to analyze the code, measure, report. You can have plenty of dashboards, histories, etc. Okay, but now, and this is, I would say, pretty much the story of my life, at least at Sonar Source. Knowing is one thing. This is great to know, but this is only one data point, which is once you know, what do you do? This is a question we get all the time. And at Sonar Source, when we started 15 years ago, there were 3 software engineers, all super keen, super motivated. That was our company. We thought it was a big thing. Every developer should be able to do clean code. And what we realized after a few months is that we were absolutely unable to meet any of our goals, which is one of the goals I remember at the time was we want Sonar to have 70% of code coverage. So every time we were coming close to a release, we were using Sonar to look at the coverage. And every time we were falling short, like 65, 67, 68. And what we were doing was we were looking at the biggest files or biggest classes where with a single test, we could actually cover as many lines as possible. We were adding the test, and we were getting to 70%, and we were super happy, and releasing the product. I mean, we were super happy the first time. The second time, we were like, okay. The third time, we were like, okay, we have a problem, which is if us, 3 people, who have created their company, who are highly relying on their software, who believe in clean code, we cannot reach our objectives. I mean, there are probably going to be very, very few teams in the world that can actually reach these objectives. So we started to think about, okay, what are we doing wrong here? And we had all this information, on all the information we needed on even more, and we couldn't reach these objectives. So we started to think, how can we have an impact? How can we make it that whenever we come to a release, we are able to reach our objective, we are able to release and feel very comfortable that we did a good job. And in order to come up with something, we really had to change the way we were looking at the problem, which is we had always been looking at the problem as, okay, this is the quality of my code, and this is my objective, and I need to reach that objective by changing my code. And actually, what happened when you do this, you actually, if you think about like a water leak, which is, I think, a similar problem, it's like if you have a water leak, you were looking at the water which is already on the floor, and you were saying like, okay, where do I start to mop? And if you think about the water leak, actually your intuition will tell you that before mopping, you should plug the leak. You should fix the leak. Otherwise, all this effort is wasted. And here, for the code, it's exactly the same, which is when you look at the state of your code, you're looking at the water which is already on the floor. This is done. This is in production. This is running. And you still have all the developers on the project, on the application, which are writing code, changing code. And if you don't change the way they do it, actually, you're wasting your time when you're trying to mop the floor. This is really what we change in the way we look at this problem. And then it starts to become a very simple problem, which is, as the first thing you want is to fix the leak, the first thing you have to do is you have to put some sort of gate on the code that you add or the code that you change. So, call that a quality gate. On what we are saying is that, okay, if you are going to change code or if you are going to add some code, this code should not have any big problem. So basically, any issue which is whatever, critical, blocker, no, it's a no. You cannot push into production knowingly some security problem, stability problem, robustness problem. You cannot do that. And when you think about it this way, it's actually, I would say, what I called basic coding hygiene, which is why would you do differently? So developers, if you do this, they will fully be responsible for their code. It doesn't mean that the code that was written 15 years ago will be their responsibility. Not what I'm saying. What I'm saying is that the code that is being done now should be clean. The other thing that will happen is it will be a forcing function to learn, which is sometimes you have no idea why tools are reporting a problem. And you are going to have to learn this. The big upside also, and I think this is super important and I want to insist on this, is with this approach, this is forward-looking, which means you don't start with a backlog. When you look at your entire application, what happens is you are kind of trying to solve the hunger in the world, which is you are trying to solve some problem which have been piling up for 15 years. Here what we are talking about is, hey, all the code that is going to be written in the future should be clean. So back to my example of code coverage. Think about it. Let's say you have a team that hasn't really mastered, that is not mastering yet code coverage. You want this guy to start working unit tests. Your application is tested at, let's say, 5%. What you are saying here is the new code, the code that is changed, should be tested at whatever, 30, 40, 50, 60, 70%. You can pick any number so that you can pick a number which is in line with the maturity of the team, because not everybody will be able to write unit tests that will cover at 80, 90% to start with. So you might need to ramp up. And when you are going to pick 50% and actually meet this objective, you are not building a backlog for the future, which is when you pick 60% next, it's going to be for the future code again. This is super important because it doesn't force you to choose objectives that are outside of what you can of what your team can achieve. Okay, so basically with this approach, all the code that is changed and added is clean. What about the legacy code? This is the other big impact, which is because we keep changing code, this is our life, and companies change about 20% of their code base every year. It means that if you start with code which is entirely bad or junky or whatever, after 1 year, you are going to have about 20%. In average, you are going to have 20% of code which now is clean. After 2 years, it might be 30, 35% of clean code. There will be overlap with year one. After 5 years, it might be as big as 50%. Think about it. Half of the code will be clean. Half of the code will not have all these problems that we can see today. If you think about it, if you wanted to clean up your project today, half of your project, that would be a huge effort, which nobody would be really to go into. So basically, by taking this approach, you also pay back the past. Where does this whole clean as you code happen? It doesn't happen at a specific step of the development process. It actually happens within the development process, which is, of course, it starts in the IDE. You can probably catch 90%, 95% of the problem in the IDE. Some of them you cannot, because some of them require techniques that will be too heavy to run in an IDE. So they need to happen after that. So it starts in the IDE. It will continue wherever you do the code review. So most likely pull request, change request, merge request, where before merging, the developer should make an informed decision, like, okay, am I adding problems here when I'm merging the code of my colleague? And it's going to continue into every time you want to promote the code, you need to make sure that nobody is introducing new problems to follow the clean as you code rule. So basically, then you have a quality gate which is common to all your application, all your technology, all your teams. It doesn't matter what's the maturity of the team. It doesn't matter whether it's a new project, a legacy project. It doesn't matter whether you insource, you outsource the development. You can have the same expectation of quality for all these use cases. So, just quick summary to say again what was said here. 4 big points. First off, bad code is not fun. This is not a great work environment. Clean code is a much more enjoyable environment for everybody. Developers, engineering managers, business, everybody enjoys clean code because you actually do what you are supposed to do when you have clean code. 2 is knowing that the code is not good is not enough. I mean, once you know, what do you do? How do you impact? In many organizations today, people know. These tools like Sonar, they have become like a commodity. Everybody's using Sonar, but the question is to do what? How do you put some policies, guidelines that will help to improve the code when solving should be really your objective? And we think that clean as you code is really the simplest, most impactful way to close this gap. You add no extra step here. You are just asking people that whenever they change code, they add code. This code actually has the right level of quality. And I do not personally believe that writing quality code costs more than writing bad code. It's only bad code could cost actually more because once you pushed it, you are most likely going to have to fix it. And this is it for me. Thank you very much.
You were late, so I'm paying you back. So, great. We have a few questions, not too many. Okay. Do you also take things like DDD or other architectural concepts into account when analyzing whether new code is clean?
We take certain frameworks into consideration, not all of them. Which framework was that?
DDD.
I'm not sure about this.
Domain-driven design?
Domain-driven design. No, we don't.
You don't?
No.
Can we always 100% rely on Sonar?
Of course.
Of course.
I think we do a good job in this. Of course, given the techniques that we are using, there are always things we cannot find, and there are always things that when we find them, they are not always exactly true, but most of the time I think we do a very good job here.
Mm-hmm. Ever thought of Sonar as an educational tool?
Yes, absolutely. You are going to learn stuff in Sonar.
Okay. Is Sonar pricing based on scanned code lines or the lines the project have? And how are returns calculated when only a part is changed?
SonarCube, SonarLint are open source tools, which are entirely free. It's only when you add certain features that there is a price. And that price is based on the size of the project, not the number of analyses. It's just the size of the project.
Like the file size of the whole project?
Lines of code.
Traffic?
No, total size.
Total size,
Yeah.
okay. Cool. Jesus, some of those questions need linting. Do you use AI during analysis? I guess some machine learning is happening, right?
We do not for the analysis itself. We use AI to refine results.
Okay. I guess that was it. One thing we talked about earlier, like how do you solve the problem that people take presets that might be too strict for their environment, but are too lazy to customize it to their needs?
I think we solve it with a clean as you code, which is because you don't look at the legacy, we are actually talking about the code that you write now that has to be clean. So when you think about this, I think the strictness doesn't matter anymore. It really matters if you look at the gap between your entire application with where you want to be, where if you enable a rule called magic numbers, you are going to have 40,000 issues, which you are never going to fix. But if now you say, hey, no new magic numbers, it's really much easier to handle. So clean as you code actually takes this problem away.
Okay, cool. So do you think how do we get people to invest more into analysis while they develop rather than doing it as a testing step?
Say that again?
My problem is that we have a lot of systems that actually use the ICD to do some testing when the code has been written. But the uptake of customizing your IDEs or customizing your environments to show you while you're coding that you're doing something wrong is not as high. What can we do about that? Is it a UX problem? Is it something that people think it's too expensive? Or?
Yeah. No, I think it's a good question. I think the problems actually start from the end, which is today, when teams are going to release their projects, there is no predefined set of rules that have to be complied to. If you start there, then it's going to be very natural that you test that before. And the last moment you can, the first part, sorry, you can test it is when the pull request happens. And developers, once it becomes like, hey, I'm not merging this because there are issues, they will want to install something that can test these issues in the IDE. So I think if the rules are very clear at the end, little by little, it's going to go back to go on the left, where people are going to have to preempt problems rather than solving them after they happen. But it has to be super clear. The rules to release have to be super clear.
Is there a full circle? Like when you do an analysis and you get the error report at the end of what is not clean, could you generate a custom linter from that?
A custom?
A custom rule from that for your IDE?
To solve the problem? Or?
Yeah, to solve the problem, basically.
Yeah, we do that. We have code fixes, which you can use. They are a shortcut to fix the problem. But it's limited. And you will never want to apply this massively, like I'm going to solve this 2,000 problems by clicking a button. There would be too much impact.
Because one of the questions is about, what about ChatGPT generated code? Is it clean? And the answer is, of course, no. But, I mean, ChatGPT allows for plugins. Could you use Sonar inside a plugin there to automatically lint it while it's showing?
You could, but that would have a limited impact. I think ChatGPT at some stage will generate snippets which are clean, but it doesn't mean the overall code will be clean. So I think it can help a little bit in the short term, but not in the long run.
Excellent. Well, that's all we got time for. Sonar are here in the expo hall as well, so you can ask more questions. If you ask more questions on the app, he's going to look at them later and answer all of them perfectly, and then we go from there.
Okay.
Thank you very much again.
Thank you, Chris. Thanks.
And here we're going to be back in 10 minutes, and we're going to talk about Vodafone.